So representing aqueous reactions. We can write equations that describe reactions in a few different ways. We can have a molecular equation. This is what we tend to think of as a regular, normal equation. This is going to show the complete neutral formulas for each compound in that aqueous reaction as if they existed as molecules. So here, potassium hydroxide aqueous. So it's dissolved in water. This is a soluble ionic compound. We know that that's going to be separated into ions, but we're going to write it as if it was together. Here, magnesium nitrate is soluble, but we're writing it as the compound, the neutral compound formula. And then over here, we're going to get potassium nitrate and magnesium hydroxide. So they're all the formulas for the neutral compound. So this is useful for most things, but this doesn't actually describe what's happening in the solution. So a complete ionic equation is going to show all of the ions that are present as they are actually present. So it's going to show this aqueous compound as potassium ions and hydroxide ions separate from each other, magnesium ions and nitrate ions separate from each other, potassium ions and nitrate ions separate from each other. This one, though, is a solid. In that beaker, or whatever it is, the magnesium and the hydroxide are not separated, they're together. And so then we'll write that as a neutral formula. So complete ionic equations tend to get really long. The net ionic equation we get from the complete ionic equation, this shows only the species that actually change. So there are some ions that nothing happens to, and so we don't show those because they don't really matter that much. So let's learn how to write complete ionic equation. So you need to start out by taking anything that's an aqueous ionic compound and write it as individual ions. So what things do you do that with? Aqueous strong electrolytes. So that's going to include soluble salts. Salt is another word for an ionic compound. Strong acids ionize completely, so those need to be written as separate ions. And strong bases. Well, those are soluble metal hydroxides, so we don't need to worry too much about that term right now. If you have something that's a solid, a liquid, or a gas, you're going to write that as an intact molecule because it's not separated into ions. So if it says S, L, or G as the state symbol, just leave it alone. Copy it down. That's going to include insoluble substances, weak electrolytes, non-electrolytes. So weak acids are going to be in that category. So you need to be a little careful when you see an acid. You have to identify, is it a strong acid or a weak acid? If it's a strong acid, separate it into ions. If it's a weak acid, leave it alone. So for this molecular equation describing a precipitation reaction, this would be the complete ionic equation. Lead nitrate is aqueous, it's soluble. So we're going to separate that into lead ions and nitrate ions. No charges are listed in the molecular equation, but we need to show charges in the ionic equation because there are ions, and ions have charges. PbNO3 what that means is there's one lead ion and there are two nitrate ions. So down here we're going to have one lead 2+ ion and two nitrate ions. This 2 comes from that subscript. I don't want to separate nitrogen and oxygen, though. That's an intact polyatomic ion. Here I've got 2 formula units of potassium chloride. Separating those into ions, I get 2 potassium ions and 2 chloride ions. On the product side, PbCl2 is a solid. It's nice when you see SL or G because you don't have to do anything. Just copy it down. There we go. AQ again, so we have to separate this. 2 of those units, that gives me 2 potassium ions and 2 nitrate ions. Any questions? So when we look at the complete ionic equation, here's that same equation just kind of spread out a little bit here. If we look at the nitrate ions, nitrate ion is present in the reactants and in the products. Pointer. Oh, over here. Did anything really happen to the nitrate ion? No. Nitrate is one of those people at the party that, you know, they're kind of like, oh, yeah, those guys are necking on the back porch. Is that what they still call it? No. Making out? I'm old. Didn't get involved in a relationship. Just hanging out. Potassium. Nothing happened to potassium. Just hanging out. Something happened to lead, though. Lead came in, kind of a free agent, and now he's hooked up. Same thing with chloride. So the spectator ions, the ions that don't get involved in the chemical reaction, they're not participating, so in a net ionic reaction, we don't include them. It's like your net paycheck. You know, that's what you actually get to take home. But that's not your gross paycheck. They took out all the taxes and junk, right? This is what you get to take home. That's what's probably more important to you to know. It's like, well, how much do I actually get to keep? So the net ionic equation is the ions and compounds that are actually doing something. So we just cross those off, cross off the spectators, and write down what's left. If you were careful in writing your complete ionic equation and careful in copying things down, it should be balanced already, but always a good idea to double check. Okay, so let's do an example. Consider the following reaction occurring in aqueous solution. Write the complete ionic and net ionic equations for this reaction. So we're going to look at these substances and we're going to pay attention to the state symbols. If it's aqueous, there's a good chance we need to separate it into ions. So looking at this first one, HI. Is that an acid? Yeah, it's an acid. So we have to figure out strong acid or weak acid. It's a strong acid. So strong acid does get separated into ions. So I'm going to write those. I'm going to have 2H plus, that's aqueous, and 2I minus, aqueous. Because I have 2 of those molecules, so I'm going to get 2 hydrogen ions and 2 iodide ions. Barium hydroxide, aqueous. This isn't an acid, it's just an ionic compound. We're going to separate it into ions. So we're going to get a barium ion. OH2, we're going to get 2 hydroxide ions. Any questions? Let's go to the products. Here I have L. L means this is a liquid. Don't split it into ions. Just copy it down. 2H2O, liquid. And then barium iodide, this is soluble. It's not an acid, so I definitely need to separate it. So I'm going to get barium ions, 1 barium ion, and 2 iodide ions. Nice, I got that on one line. If I'm careful with the formulas and the subscripts and the coefficients, it will be balanced. You should always check. That's the complete ionic equation. Any questions? To write the net ionic equation, we're going to look for the ions that don't change, and we're just going to cross them off. So, what's one of the spectator ions? Yeah.
Why is it 2I negative and not I2?
That's a good question. Why is it 2I minus and not I2? This is an ionic compound, and so we have to write this as the ion, which is I minus. This is not iodine by itself. That would be I2 because iodine is a diatomic element, right? But It looks like I minus is alone here, but she's not really. She came to the party with barium, so she's not all by herself. So BaI2, there's one barium ion and two iodide ions, and so we write those as 2I minus. It's an excellent question. So what's one of the spectators? The iodide. On the left, in the reactants, we have 2 iodide ions. And on the right, we have 2 iodide ions. And the barium. So barium was present in both places. They came to the party, they came to the beaker. They didn't get involved. They were just, hanging out watching. What did happen is that hydrogen ions and hydroxide ions got involved with each other and they made water. So for the net ionic equation, I'm just going to copy down the parts I didn't cross off. Is there anything a little funny about that balanced chemical equation? What about the coefficients? They're all 2. Do I need to have all those 2's? It could be balanced with 1's, couldn't it? So if this was a multiple choice question, I wouldn't try to trick you with this. But this would not be listed as the correct answer because in a balanced chemical equation, we want the lowest coefficients. So there's one correct balanced chemical equation. So just cross off the 2's. If you were doing this, on a show your work problem, I probably wouldn't mark you down for that, but I would cross the 2's off for you. Any questions?